So the hybrid mode is not as more technical challenges. Oh, that's fantastic. Is it okay? The camera? Okay. Okay. So I would like to welcome everybody to the EOS Distinguished Lecture Series. We are very happy and honored to have with us today Professor Youmin Zhang from Concordia University in Canada. As you know, the lecture was supposed to happen yesterday. However, Professor Zhang missed his connection from Canada, so he couldn't make it yesterday. So we are very happy to have him here today. And he's also joining us at the conference, which is actually starting tomorrow. So, so we are taking this opportunity to bring him even for a little bit here at EOS Center of Excellence, and hopefully it would also be an opportunity for collaboration in the future. I think we know each other for many years. Yes, so, thank you. So Dr. Youmin Zhang is currently a professor in the Department of Mechanical, Industrial, and Aerospace Engineering at Concordia and the Concordia Institute of Aerospace Design and Innovation at Concordia University in Canada. His main research interests and experience are in condition monitoring, health management, fault diagnosis, fault tolerant control, and also in many applications, but mainly in unmanned air vehicles, as well as ground marine vehicles, with application to remote sensing and forest fires, smart grids, and so on. So he has a lot of research experience in some of the areas that EOS researchers are working in. Dr. Zhang is a fellow of CSME. He's a senior member of AIAA and IEEE. He's the president of the International Society of Intelligent Unmanned Systems and a member of the technical committees for several scientific societies. So the presentation today is making autonomous systems smarter, safer, more reliable, and more resilient, which of course is a very timely topic, and we look forward to your presentation.
Thank you very much. Which one should go back? This one's go back? Okay, yeah, so first of all, it's my first honor for coming here. Thank you, Professor Maris Polico, for the invitation. When we have the chance to visit this award-leading research center of chaos. So it's also the first time I come here. So it's my great honor. Thank you very much. So like you can see the title I mentioned here. So all this is a world-leading research outcome in the Health Research Center. So my talk is basically just like a report for our current research efforts. So hopefully we get a chance later on for more collaborations. I also see several friends also from China. So I also have a lot of collaborations with the friends and of my students in China also. So this topic, like Maris just told, it is relatively new. It's also the challenge of subject. So if you look at the title, there are 4 keywords for smartness, and also the safety, reliability, and the resilience. So to be honest, this is still going on research. So even my group, I think worldwide, we still need more work to do. But I already see the excellent work actually in the chaos before this seminar. So you can see the very leading research work or demonstration order show. We really learned a lot. Yeah. Anyway, so this actually just a quick view for my office. My office actually just in this corner, in that what we call the UV building. So we have 2 campuses. So probably you were in Montreal before, but welcome you come to Montreal. So just talk to me if you had a chance to come to Montreal. So this is actually a one-page summary of my research. My research actually very tightly linked to collaboration with linked to Professor Couple's research. We know each other more than 20 years ago, even a couple in States. Work on the neural networks. I read your paper 9 years ago in 1995, around that time. So we are also continuing work on that for the model-based method in general, also neural network or deep learning-based method in general, model-based method and AI-based method for the modeling and the monitoring and the diagnosis and the photo control. That's how the topic, as you can see the title, with that 4 keywords in general. So recently, because that collaboration with all my students, the research associate, or the visitors, so we have a good somewhere, yeah, in my, like in North America, myself is only the boss, not like here, we have so many larger group. So we will have some research publication, and it's try to get some research result towards solving the practical engineer application problem towards that smarter, safer, more reliable, and more resilient towards the autonomous system. In general, we mainly focus on that unmanned system. Like also, I saw the several researcher this morning. So we also currently work on that drones and smart grids. We also similarly work on this field. So this actually, yeah, is of some Chinese work because there's a collaboration with the research in China. So this actually is a little bit too small for the research publication in terms of a review paper. So recently we have one, as you can see, maybe overlap with the first paper, just published a few days ago. So with that in the proceeding of I2B, which actually is some review papers for the wind turbines in terms of smart grids. So then just talk about the model and the single-phase condition monitoring for the wind turbines, for the single wind turbines or multiple wind turbines, we call the wind farm. So, but and it's just published a few days ago. So this year, this year, we have also another one, mainly for the drones, for the multiple UAVs with that what we call the fault tolerant orbit control. So, but also in that paper, 2 papers, we also touch to that sub-attacks for the wind turbines, for the smart grids, and also in the formation flight of the drones, and also UAVs, UGVs, whatever. So, but I mean, so it's just a list of these papers we published more related to the review paper for the field. Oh yeah, I think I still need that one, otherwise cannot go forward. Yeah. Yeah. So okay, thank you. This actually is the books we published. So the one actually we published earlier in 2003. So this also at that time I worked with Dr. Zhang in West Ontario. So this is published that long time ago. Last year we have 3 books published. Then with the spacecraft applications and also for the drones application. So the second one is Chinese. It's one of the supervisors sitting here from NUA University. So also have another one. It's also Chinese for the autonomous cars. So then we have the paper and also the book published also last year. We have 4 books published with the Chinese, English and the Chinese. Anyway, so just for information. So also after John to Concordia, so I have so many visiting scholars, visiting students, and PhD master student. What I can report here mainly because my collaborator students work actually. Currently also have less, yeah, but still more students from China, from different locations worldwide. So our work mainly focus on the 2 subjects or 3 subjects for the unmanned system. For the unmanned system on the space, on the air, on the land, on the surface of water. But we didn't do too much for underwater. Even when I work in the Aalborg University in Denmark, also try to go that directions. But still, just to try to give a solution for the safety issues for this kind of applications, general for the unmanned system. The second subject basically related to that renewable energies, smart grids, but also try to look at that the monitoring issues, diagnosis issues, safety issues. Now actually go further for the resilience you see in the presence of a cyber attack. So that is a general idea of information. Anyway, so this is some outline. So I try to go quickly because we have only 1 hour, so less than 1 hour. I have more slides, but I need to go quick. I know you are the expert, so we are sharing so very common interest research university. So some subject I don't need to explain too much. I think just go over the ideas behind. But anyway, as I mentioned, related to that, smarter, safer, more reliable, particularly for the more resilient of the autonomous system or unmanned system in terms of the vehicles and also smart grids. So what is the general concept? Me, at least myself, we still not reach that state. So this my report basically is some kind of an open problem. How to think about what is the future. Of course, our leaders here, our Chaos Research Center did a very excellent leading research work. We are trying to make the autonomous system, particularly like I call this autonomous system, maybe focus on the unmanned system. We also treat that wind turbine, solar panels as some kind of autonomous system in this way. So try to make all this system smarter, safer, and more reliable, and more resilient. But anyway, behind this work, so we are mainly probably, I think, mostly in the control field. But we basically ideas, so we should not only stay on the control theory. Maybe you have to go more extensions toward the communications, computations, networks in terms of the cyber-physical system with different applications for the vehicles and for the renewable energy smart grids in general, or towards the smart city application, as also stated this morning. So the next demonstration. So anyway, so what is the challenges behind that? In addition to the basic functions, toward that necessary functions. Of course, when we have the abnormal behavior occur, then we have to maintain that smartness and more challenge with that safety, reliability, and resilience. That's also one point. But anyway, we still need a long way to go. Although there are very some research, particularly in the Chaos Research Center, excellent research center. I know you all the data expert work. So the ideas I just show here, so the information as this empower the European project. So for the smart grids, for the power line monitoring, whatever for this management in terms of if there's some physical failures occurred and the cyber attack occurs, then how to maintain the efficiency, performance, and also safety resilience of all this system. Or all this is a good example here. So anyway, so this also shows the keywords. Basically, this I just try to borrow that definitions given by this Berkeley University. They try to define what they call the CPS, cyber-physical system. So in that sense, we are, as I just mentioned, not only the control. We are, of course, control still play very important key roles, but we need to also extend, do the integration, extension, combinations with the knowledge of the techniques, with the communication, computation, hardware, software, in terms of the physical layers and the cyber layers. Then try to get the full solutions for the real system applications. There's a solution for that. So the keywords behind that, that's why I just list what here I mentioned in terms of different applications. That's also my group work. We try to work on that with different unmanned system on the air, even in the space, and on the land and on the water. Try to do that collaboration between different types of vehicles for the single one and more challenging for the multiple one. I saw that example here before the lecture. So then for smart grids also, we didn't have that. Like I said, you have also the operative. That company actually just nearby my office in Concordia, 2 or 3 kilometers away. So I went to that company. We didn't have that hardware, unfortunately. So, but we are working on that in terms of the simulation level. So we also built some simulation benchmark for helping us to validate some algorithm developed towards that the smart grid applications in terms of the safety and also the resilient solutions possibly. So then the keyword as I showed here in terms of how to make all this unmanned system, autonomous system smarter. And that is what we call the autonomy or autonomous functions. Also the safety, make the system safer. This is related to so the research work here, the excellent work here for that monitoring, diagnosis, and photo control applications for the single agent or multi-agent. So then really to that reliability with good functions last about a long time. So now actually relatively new. We are talking new, it's still not totally new. In the country field, even starting from 2016 or even earlier, the couple of years data excellent work also had a publication earlier. So, but it is still relatively new compared with like a safety, resilience, make the system more resilient. It is still some more work to include also macro in general. So that's also just how to make this kind of autonomous system smarter and also safer, more reliable, and more resilient. That is the idea behind. And so I try to extend that ideas from what we did earlier in terms of monitoring, diagnosis, and photo control. Now try to extend, maybe extend that ideas toward that cyber-attack situation. Give the solution the person's abnormal behaviors when that the physical failure occurred or cyber-attack occurred in the different autonomous system, making the system smarter, safer, and more reliable and more resilient. But of course, still a lot of work to do. So anyway, so this is actually the my lab view, the lab views earlier. So let me see, we have all the toys. But also a good chance we have not so advanced like we have here in Chaos, because small group. But really, unfortunately, get the support from the industry. Probably do have the sponsor devices. Yeah, since I joined Concordia in 2007 or end of 2006 from Denmark, from our university Concordia. First year, I have a chance collaboration with this sponsor company. That's also we have so many toys from Quansa for the drones. That drones, as I can see, we call this drone. It's the first generation. That was because that in strategic ground, Quansa include the operative is two of that inter-supporting organization for that research. So fortunately, finally, we have this platform, the toys developed through that project. Of course, it is a product from Quansa. So since then, we have many years of collaborations with all these toys. The Q4, and this called the Q1. So also we have now that called Q car. I saw the NASCAR here. You build also with the, I actually also have two that Q cars in my lab. You see, it's small, even smaller than what you have. I don't know what the name for that car. So this is called Q car. So we have two. But recently, supposed in June, Quansa also announced that virtual reality with that real cars then work together for the smarter city traffic light, for all these traffic applications. So this also, we have that, as mentioned, the DJI M300 drones. So we use that to mimic the forest fire with smoke and flames and try to generate some result for that. Okay, hopefully I can show that video. Because this is not my computer, it's a little bit not used to. So maybe I can show. Yeah, sorry. So I have the video, just show. I have or maybe you cannot show the video. Show the video or not? Yeah. No, just abandon the inside. No, just abandon. Yeah, if not show videos, that's fine.
This one.
Suppose this video. Maybe it's not.
It's not.
then the link doesn't go.
Yeah, probably it's not a
we
link
didn't,
support.
we
Yeah.
use the USB flash. We didn't copy. It's from the original file. It's in the original file.
Oh, that's fine. That's fine. So, but anyway, the video is available in YouTube. So I have a YouTube channel in YouTube, so you can watch that video. Yeah, in that location, you see all the videos are actually uploaded on that website. So I didn't think I not use my own computer, but I suppose I can show that. But anyway, so not so we also have a short time, so then I need to show the video. So this is actually the one we should have the onboard. We use that also for the teaching purpose earlier for the flight control system course offering, and also offer the fault diagnosis fault control system in Concordia. Even when I was in Denmark, also offer that course. So then we can continue work on that direction to mimic the situation when the damage occur in the propellers, then try to achieve what we call the photon control for the drones with 4 propellers. But suppose ideally, what is the key behind the photon control? We need a hardware redundancy. Then photon control is some kind of analytical redundancy management. So then just try to achieve what we call the photon control implementation. We have tested the result for this cable ground previously with videos. I think that this video all cannot show probably. But yeah, even that is showed by CTV News. This is one of the central television in Canada. So the one actually because of Amazon, so they want to use that drone to deliver goods, which happened in 2012. So we also built that indoor swimming pool, try to mimic USV on the surface vehicles together with the UAV, so the UGV together. So then try to do this different application. Particularly we work on that the forest fire monitoring applications, which combine the vision, the imaging processing together with motion control of single or multiple drones with that application. Suppose I had a video behind. So I don't know. So suppose it can show. Yeah, probably it's a totally different system. Yeah, so the first time I cannot show the video. So I mean, that's fine. Yeah, no, it's not because I didn't copy this.
No,
yeah,
no,
that's fine. Yeah, that's fine. Yeah, yes. Yeah. Okay, anyway, so we have the short time, so maybe not necessary to the videos. You have see the pictures. We assembled this fixed wing airplanes from scratch from beginning, and behind that also the single rotor helicopters with that the gimbal. That is the one actually we built a long time ago. So with the color cameras, infrared camera, laser finder, laser range finder, so whatever. So try to do that mission for the forest fire monitoring applications, power line monitoring, these kind of applications. So this is pictures we took earlier. So anyway, so this just gives you some things what we are doing now. So the challenges, like I said, is still like a 4 keywords structure. So then in terms of what we call the multiple agent system, now people more call the CPI, cyber physical system. So what are the main difference? We consider the control, but more the network connections, computations, and the communications around. So main difference about that control, we have to differentially consider the communication issues we have and try to solve that for the multiple agent or multiple vehicles and multiple wind turbines or the solar panel arrays or whatever. So then that's also we can work together with the control engineers, try to get some good solutions for this different application. General, like you can see the formation for the air refilling and the wind turbines or solar panels. So we basically try to work on that towards that, as I mentioned here. So then for the 4th subject, how to make the system smarter and safer, more reliable, more resilient. How to extend in simple words what we learned from previous work of monitoring, diagnosis, and photo control to be extended to more realistic scenarios by considering all the networks, communication, computations, hardware, software in the physical layers and the sub layers. So it is a challenge, but it's still direction to go. So this actually just a copy from that the one from Berkeley. They plot this diagram. So highlight that the cybersecurity is that the framework of a cyber-physical system. So really try to get a solution with embedded computer and the networks. Then of course key concept or key technology behind is control, but through the networks for communications and the computation limitations. Then because that the communications also naturally have that cyber attack to be occurred, then we have to find the solutions for these situations. We call the overall safety and security, SMS. And for the different application of smart grids or unmanned system, we treat that as an autonomous system. And so I don't have time to explain more. We just show that what are the unmanned system in the air, on the land, on the surface of the water, under the water, on the space. And that definition from this FAA. So we try to, what is the definition even at this stage in terms of autonomous operations? So the safety, that is the two necessary functions to achieve, but not actually consider more. But anyway, just go very quickly for what we need to transform with that UAVs. If you're interested, you can read that paper talking the progress in the aerospace science in 2016. We work on that the sensor board function for the drones. We published one review paper basically try to get the understanding for the field. So the vehicles on the ground, or of course, some kind of military applications, special applications. We are more interested for the commercial applications, like the autonomous cars, like we have saw that in the center early morning. So we also work on that. You see that as a result from the research in Jingdong in one of the company. My student we work together for delivery of goods with the UGV called Jingdong autonomous cars actually. We also have a paper published as a review paper. So USV, surface vehicles, and UUV, under the water vehicles. What is in common in terms of control point of view? So we need to solve this with this hardware, actuator, sensor, and more important controller through the network, through the communication network for achieving the different objectives for the USVs. And the functions with this is 3 keywords. We call it GNC, guidance, navigation, and control in general. Even we will try to combine these 3 functions, not only C, but combining with G and N, this does not work. Think about the autonomous cars. We have to implement that. So this is actually somewhere linked to the smarter or smartness of this autonomous system in general for the different type of system. For the vehicles, then overall we have that corporations around this G and C. How about now we can get solutions for general autonomous system. In general, if I understand correctly, just you can give me a quick help for what type of general autonomous system. We need to give the solution, think about all this perception and the decision making and the execution. Then we need to look at the overall from a CPS point of view, combination of control, communication, computation, and sensing and execution. So all these things together to make the system smart, or even smarter. So even for that direction, still a lot of work to do. Also, the currently in the research worldwide, people investigate many new technology, new methodology for the practical solution. So the single ones, single agent or multiple agent, or even different type of agent. So then that is what we for the different, for the smartness. So with different applications, I can see here for the power line or the city surveillance. And currently we are mainly work on that for the first fire monitoring and also power line monitoring. So this overall also try to get a solution for the smart city, but still doing some theoretical research phase in that way. Try to overcome get a solution for this challenge application issues behind. So this is also the CTV news in 2013, almost 10 years ago. Also, we are working on this because that Amazon tried to deliver the goods use drone for 30 minutes until now, still not go to the commercial applications due to the policy issues. That's also give us the information. what kinds of technical issues, we still need to consider that the policies or the application issues behind. But anyway, the people still safety security issues behind. That is also the challenges we face for us toward the real applications. So like agriculture applications for monitoring, but in that case, not only control, imaging processing, perception, and decision making, and execution with field controller with this different sensing application like a power line monitoring, this kind of application. So I mean, for the first of all monitoring, this one real scenarios happened in 2016 in Canada. Historically, the largest forest fire occurred in that year. So you see it looks nice, but we do not really want to have the situation occur. So that's also basically occurred in 2016, May 3rd. So even damage to that small town in this location. So anyway, so that's also we starting this research since 2013 based on the theoretical research. So we currently work on that, try to get solutions by combining with neural network or deep learning method for the imaging processing. And of course, still need to solve that control issues behind the motion control issues. So this result, very preliminary result, I use the deep learning method to try to detect the forest fire in a small stage and all these waves when the forest fire occurred in that state. So then we try to use drones. Then naturally also need to consider what if the fault damage occurred during the mission. Then we have that called FTCC. What the FTCC means? Fault current cooperative control. It is basically just extend to the multiple vehicle or multiple agents for achieving that occurrence capabilities. So that's actually the ideas we are trying to solve that problem for the forest fire monitoring with different types of vehicles, fixed wing or rotary wing, and try to get a solution for that fire detection, fire diagnosis, and the fire prognosis. Basically, it's an extension from our traditional fault detection, fault diagnosis, and the fault prognosis. When we read that review paper in 2015, well, I think why we can extend, why not can extend this from that current control issues to the application to forest fire. This is also abnormal behavior. That's something common. That's also we put this in the review published in the Community Journal for Forest Research. This is one of my PhD thesis student thesis work in that 2015 state. Anyway, I don't have time for talking more. So we also consider the satellite airships and also USV together, try to have a better solution for all these applications. So for the single one, for the multiple one, for the imaging processing, and for the motion control together, if the fault damage occurred, then how to get that solutions with different strategies, model-based method and artificial intelligence method. So there are so many different research. Actually, my group also will try to investigate different algorithms. I will cover that later. So this is actually the cover page for that survey paper published in the Chinese Journal of Aeronautics in the first issue of this year, which actually called the FTCC of multiple UAVs. That gave the overall literature review for that field with application of the multiple drones. Actually, we try to state this kind of story. If you have the engine failure and actually the faults, that is normally for the fault control applications. Now, when we talk about multiple agent, multiple UAVs, then we have to naturally consider communication fault. Now, through the communication problem, we have the cyber attack could occur. Then we need to get a solution. But to be honest, when we write this review paper, very few paper published on this field for the UAVs until now. So more application basically related to that this review cover page, because our review paper put in the cover page. The first version, but finally decided this aerospace journals need to not talk to the forest. We got to use this picture from as a cover page of that special issue of journal. I mean, so we'll work on that as smart city with that airships for the multiple ones. We published the papers, but it's still theoretical research. If you're interested, you can look at that. Then we can do the communication exchange later. So due to time limitation, I will not go more detail. So we also work on this smart grids. Like I said, just the virtual work, still simulation level. We do not have the very advanced hardware like I see from the center this morning. So anyway, so we talk this, of course, when we talk about the renewable energy of smart grids, it's integration with the solar energies, wind energies, and also hydro energies. So, but with, of course, like this morning I introduced the batteries, of course. That's also we can two ways of communication with generation and transformation of electricity. But we should not forget the traditional good mass integration will generate a stable better performance of electricity generations, transformations. Anyway, so my group also work on this. In general, also you see that the Youmin meetings last year organized talk about again come to our center here. So for this kind of intensive research, so hopefully we'll come with some things together later. So anyway, so this actually just for this situation, I just consider for smart grids, it is currently actually more applications involved the safety issues, security issues, solutions for the sub-attack. Like also you also implement in the platform here. So we make that sub-attacks, so have to get the solutions. So then overall, it is something new. But anyway, I put some reference from also friend, Professor Zhang, and also from also the Professor previously Professor you are the editor chief for neural network learning system. Then the is after you. Now actually Professor Sung is the chief for that channel. I'm also the AE for the channel. So then how about when the physical feedback occurred, when the sub-attack occurred, then how to maintain the stability, acceptable performance for the smart grids. This compared with the UAVs is even more advanced, more results published into the Hills Research Center. So you already published papers in this field. We are trying to follow up, try to do some continued work on these directions. That we see the different sub-attacks. So we need to mimic that. Similarly, we'll work on control. We need a model. No matter we use the first principle or use the data, use different neural networks or fuzzy logic or whatever. So try to build some models to help us to do the control implementation. So similar things, I think if I understand correctly, for this kind of sub-attack, we still need to build a mathematical model, try to have a good understanding of these features and the dynamics related to that sub-attack. Then try to use the concept of what we learned or did earlier for the fault diagnosis and fault control, then goes to that. Of course, there are some special features. The more challenging, it is also called the sub-attack, attack of smart. So we should be even more smart for the attack. How to achieve that? Then, of course, do a lot of work. So anyway, if you're interested, you can see some review paper published in that is previous years. So my group, we are currently trying to work on that, but still not so many research publications. But anyway, I'll talk about that later. So we have that, this from computer science software. But anyway, so we need to do some kind of integration, combination, or extension from control theory to more computer science or the communications. It's integrated work in general. So anyway, so at least some reference paper here if you're interested with that. So what are the challenges? Still more works like 4 keywords I mentioned. Smarter, so related to that the autonomous function, or more autonomous. So they're also considering the fault. Even not only fault, in the presence of a sub-attack, how to achieve that what we call the fault detection diagnosis or sub-attack detection diagnosis. Or we can think of it this way. When the sub-attack occurs, finally lead to the physical damages. Then once we reach the physical damage, it is similar like the damage from the sensor fault or actual fault in some sense. But of course, for the something like involve the computer software through the networks, we need some special solution for that. But in general, we need a general residual. That residual should reflect to the physical faults and also sub-attack if we can. So it is a matter of how to generate the video in the efficient ways with the model-based method or with the intelligent method. So that's general. So I think that is more challenging work still. Need to work on that. So anyway, so here I just try to use the paper published more than in 2008. So it's the first paper published after Zhang to Concordia. So it's a good citation, but that one does not have any information about cyber attack, even not for the UAVs, even not for the mapped agent at that stage. So the idea is now when we try to handle that both physical failures, cyber attack, we need new definitions. Probably the couple you did us to develop new definitions for this new challenges faced to us. In the present of both physical failures, like a traditional fault diagnosis and fault control, now in the presence of cyber attacks. In the larger framework of cyber-physical system, I think still, to my knowledge, still not have that kind of definitions of the paper publication yet. Because the paper published up now and listed here, it is still more or less in the computer science, that network aspect, not in the control. Although since 2019, I noticed more paper published in, before you have more paper earlier, of course. So that is still relatively new. So how to define that? Myself, I use that different options here. But anyway, there's something in common. So suppose we should have possible solutions for this and unique definitions later. So I just open the problem, open the questions. So we'll look for the result later. Anyway, so this just show I have videos behind, not show videos. So we did that for propellers with a 70% larger, smaller level of that failures generated due to for the popular helicopters, and try to maintain the stability and the safety and the reliability of the UAVs or drones. For the single one, more actually challenging for the multiple ones. So that's also we call FDD for the fault detection diagnosis, FTC for pump control. For the multiple ones, they call it FTCC. If you look at my lecture, the keywords actually in terms of the smarter, safer, more reliable, more resilient, more linked to that three functions of FDD, FTC, and FTCC. Of course, they need more extension, like I just tried to define that in the previous slide. I mean, so this is some videos. I will not show that video. So, but I know this is a very more. I just go quickly. Like the damages in the solar panels or wind turbines for the single ones or multiple ones. So I mentioned in the introduction the Boeing, the Boeing 737, like Max. So that is the CEO. Of course, he's no longer as CEO of Boeing, unfortunately. He was that to do that, unfortunately. I have videos, but I mean, so cannot show that. So the significant loss actually due to that two loss. What is the issues behind? It is the inappropriate use of that less of the hardware redundancy because that is sensor fault, and also inappropriate off-time control strategies. They have some kind of off-time control, but of course manually by the pilot. But the two disasters, even without that good monitoring functions, lack of the redundancy, hardware redundancy, not good management of the disaster occurrence. That also happened. But I mean, this is for the UAV. I just go quickly. So, but I mean, it's just a very fundamental concept. So, but I mean, this actually I use for this review paper, try to explain the concept of what we call the fault control FTC, or look at the system FTCS for the what we call the passive fault control. Then with that control block diagram, then how to maintain the stability of some performance in the presence of not only the disturbance uncertainties, but also the faults. This is what we call the fault control. You know very well for that. So if we have the more severe fault situations, then we need a FDD function that involved. Then try to do what we call the reconfigurable control implementations. Of course, behind that, the block diagram, each of the blocks, we have so many strategies: simple, complex, linear, nonlinear, model-based, or artificial intelligence-based method. So you can, whatever the method, you can generate it, or basically generating the necessary useful residues. They use that residue basically to build online post-failure model. What if we have the cyber attack? They should some way do the similar things, but of course more challenging that way. So compare with the physical failures, because that is still basic feature of the cyber attack in general. So this is what we call the control reallocation, but mainly for the redundant actual situation, like for the airplanes. So, but of course, yeah, how to handle that actually. We have the video behind, and so I have no time to show that here. This the challenge I mentioned in that paper, I think still valid for now. So even my group, we are still currently working on that. I think here also you are working on that for solving that hardware redundancy and the lag redundancy. Then also either use an active way or passive way, considering the degrade performance or final time, fixed time, or pre-described time functions. Even we probably try to publish a paper in this subject. So model-based method or the data or model-free-based method, particularly for the using deep learning method. So, but still, I think it's still more work to do with that control part. I also agree probably the couple. So maybe for the vehicles, for the smart grid, we have the physical model. We should use that. But of course, also try to use the deep learning method, the combinations, then get hopefully better solutions. That's all. My personal opinion, of course. Like this is actually the scenario from airplanes. So they use that the hardware redundancy, of course, include the software redundancy, at least 4 triple redundancy, or even 4th level of the redundancy, because the high level of reliability and safety requirement for all these airline airplanes. So this is a layout for this commercial airplanes, Airbus 320, 40, 80. You see the roughly background for that. But anyway, I can come to go more. So anyway, so how our work can link to the industry exchange? So it is the industry requirement. So but anyway, so we cannot test in that real airplanes. But anyway, UAVs, drones, open the door. We can at least test that. Like I saw so many DJI and 210 and 300 in the lab, the center this morning. We also work on that. You see that for the M300, particularly DJI A3 Pro autopilot on board, this uses triple redundancy for the onboard computer, MUs, whatever. So this MP 2128, it is one small company in Canada. So also build that triple redundant hardware platform for the autopilot. So try to achieve that, we have this hardware SUV in my life. So, I mean, so I just go quickly, I think it's not time that. So in terms of this passive and active, and also online modeling, it is very important to identify in the real time with limited data to achieve the identification or estimation of post-failure. Because this is what we use for the quadruple helicopter, try to estimate the level of the force with other parameters. Then for the single one, and also for the multiple ones, you see, identify that with real data we measured in the indoor environment with that quadruple helicopters. So finally, so the degraded performance, that also my earlier work is published in 2008, 2003 even, but I still continually try to extend that. Well, by considering more nonlinear situations, more uncertain situations, because previously was just try to consider that it's still based on the linear model. Now we have to consider the nonlinear situations in general, more challenging situations. These ideas will try to show that the degrade performance requirement. I didn't have any paper published in the paper because after left from Virginia, I didn't have a chance to work on this continually. So, but still, we try to work on that, like this fixed time, final time, with more publication as I listed here. Yeah, this is, you see, so this years we still have more publication on this direction. So try to get more towards the real application, but although still need more work to do in general. For model-based method or the AI-based, So we also use a deep learning method, fuzzy logic or whatever, or combination with the model-based method. How to do some investigation for the single one, for multiple UAVs with different applications published in recent years. But no time for sure that detailed method. I think you as expert, you know all this already because so advanced method. So we also work on the simple that we used several years ago with that autopilot. So for the real testing with that small airplanes, so generate what we call the hardware redundancy for the rudder failure at start during the flight. Use even simple PID or gain schedule PID for the real flight testing. It's not my PID system work earlier. So this we did a flight test some long time ago in journal. So that is actually for the single one, single vehicle or single agent. For Mach 1, that's what we call the FTCC here for the Concordia control. Currently, we also work on this. But I think what we showed them this morning, we also work on that this direction. But generally, if you can see the paper we published in this subject, we are trying to do more work. What is new for this direction? Then we need to consider navigation and the coordination. That is different from a single vehicle, single agent. So how also consider when the fault of a normal situation occur, even now as a cyber attack situations, how to get that solution still need more work to do. But anyway, the paper was reviewed in that paper, which is like I mentioned, published earlier in the Journal for Chinese Journal for Aeronautics. So basically, we sum up for this leader follower behavior approach of structures of potential field method, and how this method can be extended for the abnormal situation, including the fault or cyber attack, and how to achieve that coordinations. It is still need more work to do. Like I said in that review paper, we still, and some more useful publication, but still need more work to do in terms of application for the drones, for the formation flight of the drone situations, but you get a solution for all these scenarios. Still need more work to improve our group. This is what I proposed earlier for the single one, for the multiple one, different layers. So still need more investigation to be carried out in my group. So this is what we just mentioned. You see the abbreviation of different strategies for FDD, FTC, and FTCC. So it looks like this. We mainly use the common filter-based method. All the extension, what we call the dual UGAP, or two-threaded common filter ideas behind not only the state estimation, but more challenging, more important for the induced parameter change in estimation. It is a parameter estimation or systematification problem in the real time. So it is still new work to like you introduce the user, the new methodologies. It is. Still need more work to do. In general, for the FTC, looks like a sliding mode, backstepping, model reference, and the gain schedule MPC method. So most widely used one is for proving the stabilities in the framework of the sliding mode control, the model critical control. That is to based on our investigation to perform possible powerful methodologies. Of course, we need to solve that in nonlinear situations and real-time applications. For the multiple FTCC, you see also looks like an MPC and sliding mode control. But of course, depending on problem, even use the word, but still need some new verification, new development, not like a traditional method involved. So for the corrupt control, you saw also searching and coverage. You also gave that earlier. For the landings or whatever communication loss, we try to do network since 2012 or 2013, but still continue try to get a solution for all these applications with different, like we have this choice in the indoor environment. Also now try to go outdoor. Outdoor basically just use DJI. For now, we built that the fixed line, but I still need more work to do. So behind this is some videos. I think I don't have time to do that video. So the rest of the slides, I need to go quickly. So some case study, like I mentioned, our research for FDD, FTC, and FTCC. We also use a different method for the first flight monitoring applications, combining with the motion control together. You see that the sliding mode control with also deep learning method to identify the fault magnitude, use the method developed, or use the observer method in the determined situations. For the stochastic situation, of course, we need data on the common filter or extension of the common filter-based method. I just go quickly. Yeah, you see that you know very well all the, I don't need to talk about that detailed formulations. So it is some kind of art for designing sliding surface and among the controllers to satisfy the requirement for stability and the design performance, and particularly not on the stabilization, but tracking. That is really the need for the application in real situations. Anyway, so this is some result from my previous PhD student. He's actually now in China, the first professor in my home university in China. Actually. So you see this is using neural networks, so this is different method. So anyway, so just go very quickly. I have videos behind that maybe do not time to show, and also kind of show that video. As you can see, this is also one collaboration with any student from BUA. Yeah. So from BUA, they work on that Beihang University. So this is the same. They are from Quangsheng, Q-drones. Yeah, try to compare with the ETH, the result. Yes, so we got some factor with that. Yeah, but with that limited situation. Anyway, so the paper we published last year and this year. This paper actually just accepted, few days ago, end of May. So, but I try to mimic the different situations for the single one and multiple situations. So this is actually we are also starting from 2018, even earlier, from 2014. So we try to get a solution for the FPCC, constantly follow different scenarios with different situations. The paper, small fonts here. So try to solve that different situations, including communication fault situations with a single leader, multiple leader, and complemented, and for the smart city, or the first 5 applications as the application scenario. But for the multiple ones, we're still in the simulation level. It is still challenging for the multiple system in the real flight. So with different strategies, as you can see the equation behind, try to get an general solution for the nonlinear situation, nonlinear controller behind. So for the different applications, different scenarios considered here. So this is a complementary control of multiple UAVs, but also publishing different generals. Yeah, I don't have time to show that detail behind. So for the smart city applications, for the forest fire monitoring applications, but this is related to motion control, what we call the FTCC. Then for the real solutions, we also need to consider image processing together with motion control. So this is some result. We also work on the high speed of the space vehicle for the landing state, based on the simulation work. We work also with the Canadian Space Agency earlier for the IDD, which is a long time ago actually, or use a common filter-based method. Have to use a little follow-up of 2 satellites, which is developed by this CIADI. And this is actually related to the Prisma in Europe. Already we wanted 10 participate in this, but because later they will, that satellite will be finished the mission. We just did the simulation at that time. So these are one of the current work. We work on that for fire monitoring, but use drone images and also use satellite images. Use different methods, neural net in general, for detection. Distinguish with that of smokes and flames. Use a general deep learning method in general. So with a different, I know you know that also if you work on the deep learning method for the detections. So anyway, this is one. I saw the videos also this morning in the center. So we are doing same things now with the DJI 300 with onboard camera. I saw you have a more powerful one at same platform. This actually the onboard computer on top of that DJI 300 and 300. So we can implement our own algorithm in this onboard computer for the imaging processing, for the mission planning, all this kind of state of work. So one of the paper is the CUS later on. So this we did in May 24th. In that club, we mimic that forest fire and general smoke and fires try to consider use the DGS 300 to do the onboard detections of the fire, even in the small state. So still, it's going on work, more work to do actually. Combination. This is just some explanations here. Anyway, so this actually, yeah, behind we have some there's some videos I'm gonna show that, and so you can come to my website to see that more testing result. Due to pandemic, my student also they work on that. So the mimic situation like you also showed earlier, the virtual reality situations. That's the what we call the cube car. Had to considering the traffic control issues with the onboard ladder. I think it's the same layout as you have here. So we have two. So try to do the control tracking for the single car and for the multiple cars. So, but we also have some test result here. Yeah, we'll not show that. So for the friction estimation, it's one of my PhD student graduated last year. So then also combined with that control together. So the one paper, even today, I still need to submit that proofreading for the paper accepted by CIADI for that paper. So anyway, so this is another one. So also try to work on that for the situations, as you can see. So just a report for what our results behind the different strategies, try to think about the future, transportations. Ideas we try to extend to the fourth situations. Even for the autonomous cars, the cyber attack also one of the possible scenarios. We need to work on that also in the future. So anyway, so for smart grids, like you see some control strategy looks like similar, but here we use also fuzzy logic for getting solution for the smart application for the wind turbines, solar panels, overall smart grids in the framework of that cyber-based system. Even we use that IPCC first time published in 2017 in applied energies. So use that concept learned from Zhang's extension to the renewable energies. So we need more work to do. So this is a benchmark we built, how to combine batteries, solar energies, wind energies in MATLAB simulator scenario by considering that physical faults, damages, together with that cyber attack, try to provide a solution. Currently, we work on that in the simulation, but of course, you have a better plan from here, even with hardware, software, yeah, together. So hopefully, I can use your plan from later remotely. Would be great. So this is what we did since also 7 years ago. Currently, one of my graduate students work as a social professor in your university in UAE. This is Iranian. He actually got a position in UAE to work on this. Dr. Hamid Badidi, he did the workshop in civil processing, but physically, not physically, remotely. So anyway, so this is a paper we published yesterday, but still need more work to do. Yeah, try to get that possible solutions, not only the fault, but also the cyber attack, and try to get realistic solutions for this, making all this autonomous system smarter, safer, more reliable, and more resilient. But still a lot of work to do. Yeah. So we are trying to go that more on these directions. So like we put this in the review paper here. So we only found 2 papers in terms of cyber attack in the framework of UAVs. So even only talk about that detection, not control issue yet. Yeah, but anyway, more extension to do. If you're interested, you can, it's open access and download that paper really. So the second one related to, I just mentioned the public proceeding, but this is limited to the wind turbines. So talking about that model-based database for the diagnosis and the prognosis. Also talk about that, so, like you see, for the cyber security. Still more work to do on these directions for each other. So anyway, so just to quickly report our work. So we still need to learn more from your Professor Halkapo's group. Yeah, the Chaos Research Center. You did a fantastic job. Hopefully we get a chance to for more collaboration later. Thank you. Thank you very much. Thank you.
Youmin, for the very nice presentation. You covered a lot of material, and I think it's that we have a lot of things that we are working in common. So I hope that this visit will also be an opportunity to find the ways to collaborate in the future and exchange research.
It's my great honor. Thank you.
Yes.
Thank you very much.
Let's start. If there's any questions or comments from the audience before. We also have some online people, so let's start with the people here first. Are there any comments, questions?
Thank you for the presentation. It's a more general question first regarding. You have been working with forest fire monitoring for a time now. Could you elaborate a bit more? What is the challenge? Because now we see all these fires across the world getting bigger and more aggressive, let's say. So what are the challenges of using drones in, let's say, efficiently monitoring all these fronts? I mean, from what I understand, there are different models of fire propagation and fire analysis.
Mm-hmm.
So how drones could be used in this understanding what type of fire it is and trying to find out where the fire will go in the future. So you could elaborate a bit more based on your knowledge.
Okay. In general, that is the two subjects together. First of all, for the drones, it is a motion control issues. Like you said, we need to have a prepared or pre-planned trajectories for searching for the potential forest fire, because when the fire occurred, where the location, we do not know. Of course, that's why we need a schedule in advance for flying. Currently, people use either satellite or the manned airplanes, or even for the firefighter work on the forest, or install some sensors on the land. So drones actually open the door for the autonomous flight or searching, but only fly with the desired traditional use. We need to onboard a sensor, like our human air, to see, find the potential fire, even as early as we have a small smoke, or maybe goes to the stage of the flames. So that is the second part for the imaging processing. So that's why we use a color camera, the images from the vision, and also I use infrared cameras. So basically both. So the one actually DJI M200, it is only for the platform of drones. We need a payload sensor. That sensor we use called the H20T. So that H20T basically includes the color camera and the infrared camera. So now we also have the LiDAR or the L1. So now they have H20L. So basically use a laser, try to find that locations, try to build the real-time map for the guidance of that fighter for the fighting with the fire. But currently, but of course, we need to do the monitoring and the detection, like I mentioned in the previous slide, for the function of detection and the fire occurred in the forest first, then try to gather the information further for the location, size, and the future evolution. It's a prediction. So that's overall, it's a detection, diagnosis, and the prognosis. Of course, when we use the same words, but a little bit different meaning we have. So overall, so it is a good combination with that model-based method and the deep learning method for the both motion control and the imaging process, even vision or imaging process based control. So we are currently working that use the DJI 200 as a platform then try to, once we find that the location, position location of the file, they also try to manage the motion of the UAVs for the motion control. So overall, it is motion control integration with imaging processing. Of course, involve the communications, computations. We look at if you have multiple drones with also satellite, or if you have the water, like in suppose we have that we use water for extinguish the fires. Then we also have the USB together. So then, yeah, overall, it is we can see it's a CPS framework for overall possible solution to this. The challenge is actually more related to the image processing, but probably in that aspect, you more deep learning research for the earlier detection. But even for that applications, I think, yeah, compose the power line. As far as the fire detection, even simpler. Only the matter we need the distinguish not with the fire, with the smoke. Then, if go to the power line monitoring, then we need to go details, try to find the damages in the isolator power lines. Is even more challenging for the imaging processing. So the challenge like you mentioned, overall, the systematic solution, not only one part of all, and work on the control, just work on the control and work on the imaging processing. But one person, of course, we have a limited capability. Yeah. We need like a chaos this large group, work cooperatively. If it works, then we can achieve systematic solution in general. Thank you. Yeah.
When you're trying to vote for a drone policy, like one of the road courses planning to have to speak fast and it. I presume you did a little simulation first. So my question is, which simulator are you using? And in general, when doing like autonomous missions, what kind of sensors are you utilizing? Television and LiDAR, or?
So basically now we for the fault current control implementation for the quadruped helicopter. So I didn't show that video, but actually, ideally, we should, like I mentioned earlier, for the fault control, we need to consider redundancy, hardware redundancy. So ideally, for the quadruped helicopter, yeah, if one of the propeller damaged or lost, then hardly we are not able to continue the mission. That's also, like I showed from ETS, perfect robots. So their work, we try to, yeah, reduce the severity, not hard crash, but the spinning and the touch the ground. Some ways safely. But the real solution, if we still want to continue the mission, then we need to increase the redundancy. Not only the 4 propellers, 6 or 8. That's why industry, even with the octa-count, 8 propellers, like a videos we worked on earlier. We also modify that quadruped helicopters by adding 4 more propellers. Then they come to octa-count. They have 8 propellers. Then you have the hardware redundancy. Of course, when we talk about fault control, there is a redundancy management issues, we can call that way. But behind that is a fault control algorithm. Use the redundancy embedded in the system with good control strategies. I mean, the algorithm like you mentioned. So like I mentioned, we also can use slightly more control and the model control and so some control theory could be used for that general situation. In terms of, we have the toys like an indoor test bed. We mainly focus on the real testing, but still need to do the simulation. So the system we have is based on the quantum stuff. So that is based on MATLAB Simulink. So we just developed that in the MATLAB Simulink scenarios because quantum they have a software called Quark, just to convert or translate that MATLAB Simulink use C generator, then generate do the C code, then get the compiled then the exact code download to the onboard computer for doing the autonomous flight of the helicopter. So instead, we just starting from the ground, use that platform for both quadruped helicopter, like a cube craft, or the same software platform in general. Yeah. But of course, I agree with you. We need to have a simulation for because it is otherwise it's so dangerous. Safety considerations. We don't want the last ones to do the testing of the new algorithm during the development stage.
We have a couple more minutes, and then there's a quick question.
Okay.
I was wondering, do you think that some of the problems of the phone system are solved by integrating the classical core model that we are doing learning?
Yeah, actually, yeah.
Something that people actually
Yeah, we actually, yeah, you mentioned that very important. I have one student, PhD current student, work on that. Even I didn't include here for that video. So we have the video in the website. I don't know if I can have access here. Maybe. Yeah, I didn't invite the connections here probably. But anyway, I suppose, yeah, suppose we can make the link. Yeah. Okay. Yeah. So that actually we use for the motion control, or also the obstacle avoidance. Yeah, this. Yeah, see here. Yeah. Okay. Yeah, this we call the AAV lab for the testing result. So you see the videos here. Yeah, all the videos here. I think one of the videos is this one. This I just did recently. I upload on the December 9th. This is user deep reinforcement, reinforcement learning method. But we even didn't have a paper published. Already did the real testing with that Q drone, and also underneath is a Q cup for testing the algorithm behind. Of course, it is good. We can combine with that definition, the classical control, even PID, and also this more advanced AI-based method for the more application scenarios by considering faults. But even this one does not consider faults yet. Just a very simple situation, try to land the Q drones on the top of Q cars, show the motion situations. Yeah, anyway, if you usually there are more videos up to the more than 10 years ago, when we work on that with other platform, with a different platform, with another way, because I'm not rich as the color couple in the council with the center of no money. It's so honored to have a collaboration with the Quanser. So we have all these devices available.
Quanser is in Montreal?
In Toronto. Yeah, since I joined to Concordia first day, because that is strategic grant, I have more than 15 years of collaboration with Quanser. Very good at least we have so many good toys.
Everyone loves spreadsheets. Actually, they don't. But check this out. We go to wonder.com, get started, import from spreadsheet, and
I think, even our new president come to university, come to my lab, We have two lab selected from my lab.
Yeah, I can see that.
Yeah, recently the lab will do the renovation. Later will be, more modern, hopefully. I don't know in the future, the current renovation.
I'm sure there's a lot. Okay, there's another question online, a colleague from the department. Huh?
Yes, he raised his hand. He wants to say something. Go to the chat.
This is all the videos.
Concordia University students are looking to change the way we save forests. They want.
I just stop here.
Is it possible to hear his question?
Hello, can you hear me?
Yeah, we can hear you.
Yeah, hi, Professor Zhang. Thank you very much for the fantastic presentation. it's already very impressive. The amount of work you did. My question is more related to, my background is on power systems. And as you know, as we experience in California, as the previous colleague mentioned, California, Mediterranean Sea, and so on, there is an increasing number and frequency severity of fires. And in California, there is even concern that those fires initiated by transmission lines, electricity lines, and so on. My question is more fundamental: if you ever work with an electricity utility to actually apply this kind of technology in detecting this kind of wildfire risks, let's say, initiated by electricity lines, because that is a very important topic that is currently of increasing concern around the globe, especially during hot and dry seasons, which the ignition of fires is of high risk.
California states actually offered at least 5.3 million for the forest fire fighting. There's actually, I also have a very good friend, Professor Yang. He's in the University of California, City. So even if you want to do the collaborations, so we have talked about that possibility. But anyway, so we are still currently trying to investigate some methodologies, technologies, use these drones for the future applications. Yeah, we didn't have a chance to work on the industry even actually after my first strategic grant. I also applied several years for the first 5 monitoring applications. I didn't have a chance to get more funding. But still, we continue to work on that based on the thesis, Massachusetts thesis work. So I could investigate, like I also so as the next collaboration with the concept with the industry. We have that the drones and the validation of the so it would be good actually. We can go to the industry applications. Also, the one company. That company also supported me with that several kind of applications after my first study grant. That company actually is responsible for whatever the forest fire occurring in Quebec. They, of course, currently use manned airplanes, fixed wing or helicopter for the detection and for the fighting. They also try to work on UAVs. So we still need some way to go toward the applications, like a previous question. We need to get a solution for the imaging processing and also motion control together with one system. If really we want to use a drone, just go autonomously, finding the location of the fire, and try to give the guidance for the fighting, even use drones or even autonomous fighting. So it is really the future work. Okay. We are trying to work on that.
Okay.
But we also have a collaboration with the California. I know, yeah, I didn't mention, I have the time to mention that. I know recently, 2019, it's also the power lines. That's also we work on this post first supply, and also the power lines. It is in the framework of smart grids in general. So many work actually. It's a challenge work.
Okay, thank you very much, Professor Zhang. I'm sure there's more questions, but we have to stop it here because we also have to go to a conference that's been organized in Bafos. I think it was a very informative. We saw a lot of the work that you're doing, and I think it's a good opportunity for the researchers here. And I'm sure that this visit and the presentation will have continuation, and we're going to find ways to collaborate. So I would like to thank you and thank all the audience for
all in online. Thank you.
Yeah, and thank you for the people online. Thank you for Katerina for organizing.
Thank you, everyone.